Hello, welcome to a video on section 2.7 extended, which is about piecewise functions. So I'm going to open up a new OneNote thing here. Just got to figure out where to go. Okay, perfect. So this will be section 2.7 extended. So again, this is titled piecewise functions. Let me give you an example of a piecewise function. So that what I just wrote is a piecewise function. The reason why is because you're going to graph y equals x plus 1, but only keep the portion where x is greater than or equal to 0. Also, you're going to graph y equals negative 2x minus 3, but only keep the portion where x is less than 0. So let's actually try graphing this. So I'm going to make some tick marks. Okay. So let's start with graphing of y equals x plus 1. That's easy. Y-intercept of 1, up 1, over 1. Draw a line through 2 points. Not so bad, right? Now we have to keep the portion where x is greater than or equal to 0. If we think about it, I'll go to my highlighter here. Only this portion of the graph is where x is greater than or equal to 0, because this portion right here, all the x values are obviously less than 0. So what I'm going to do is I'm going to erase. Okay, that was not smart. Well, I'm only going to keep the part of the graph where x is greater than or equal to 0. Notice how every single x value on that red ray, that looks like a ray, and that's color red obviously, every single x value on that portion of the graph is either equal to 0 or greater than 0. And because it includes 0, we're going to have it as a filled in circle right there. Okay, now for the next one, negative 2x minus 3, if we think about it, if we graph that one, it starts at negative 3, goes down 2 over 1. So here you have that line. But we want to keep the portion where x is less than 0 because you're told that. So this is a condition for that equation. That's a condition for that equation. So we only want to keep the portion where x is less than 0. So I'm going to erase the right side of the graph because all the x values are greater than 0, and I don't want that. So my graph will look like this. And that's going to be an open circle there because it doesn't include 0. So that's how I graph the piecewise function. You can actually do this in the graphing calculator, but it's a bit complicated to show on the video, so obviously I'll show it to you in class when we meet again. Another thing you want to keep in mind is that piecewise functions must satisfy vertical line test. That's because they are functions. So if I drew vertical lines all over the place, it never crosses more than once. Even if I draw it down the y-axis, notice how it crosses one of the graphs because there's a point included, but there's a hole in the other one. So this way, it's still okay. A few other things we'll do. Let's say we'll try to find the following. So let's find f of -1, f of 0, and f of 1 using the function that we have above. Well, if we want to find f of -1, remember, since x is -1, we're going to have to use that second function there. So in this case, we're going to do -2 times -1 minus 3, which will be -1. And that makes sense because here at x equals -1, y was -1. F of 0, now I'm going to use the second one because you want x equal to 0, and notice how we have the equal sign right there. So that would be 0 plus 1, which is 1. And if I f of 1, I'm still going to use the first one because 1 is greater than 0. So 1 plus 1, which is 2. So that was another thing I want to discuss in regards to piecewise functions. So we'll do this as practice in class, and that's it. That's the end of the video.